7.42. Okay, so we're looking at this problem here. Now, the first thing we did with it is we needed to factor. So the numerator, the 3x squared minus 3, well, there's a greatest common factor of 3, which leaves us with our x squared minus 1. And this here, we ended up being able to factor because that is a difference of perfect squares to this here. So the numerator ends up giving us this here. Now the denominator of this overall fraction, well, 5 over x plus 1. I had that written wrong. It'd be plus 1, so that means this is plus 1. That's already as simplified as it gets. X plus 4 on top stays the same, but we do need to factor, there's this here, the x squared minus 3x minus 4. And when we factor this here, the negative 4 would give us opposite signs, x and x, and the factors of 4 that we want are going to be 1 and 4. And we get this here after everything is factored. Now, if they'd have been nice, they would have it'd have been really nice if that had been x plus 4, because x plus 4 and x plus 4 would have simplified. So, the two methods that we have, one of them is adding, making the denominators be the same and adding the like fractions, but that's not going to be too helpful here. So, what we're going to use is the least common multiple. Now, I know I'm going to need 3, x minus 1, and x plus 1, because that's what we have on top. That's what's going to simplify the numerator. Now, if we look at the denominator, well, 5 over x plus 1, we already have an x plus 1 to simplify that. Now, the other fraction that we have has an x plus 1 and x minus 4. Well, we're going to need the x minus 4 for everything to simplify. So this one here, we're going to have 3 terms. Okay, well, time to get down to the nitty-gritty. And for our numerator, we're going to multiply the top, because this only multiplies by the top of each one of these fractions in the fractions. Is going to give us, well, it's multiplied by 1, so it's just 3 times x minus 1 times x plus 1 times x minus 4 over 3 times x minus 1 times x plus 1. And that gives us the numerator. Now the denominator, we're going to do the same thing, and we're going to multiply each of these fractions. So this whole thing is multiplied by 5, and then we'll multiply it by the x plus 4. So we multiply it by the 5. Well, 5 times 3 is 15. We'll go on and multiply that number. Minus 1 times x plus 1 times x minus 4. All over x plus 1. Minus. On top here we have 3 times x plus 4 times x minus 1 times x minus, or plus 1 times x minus 4. All over x plus 1 times x minus 4. So we have a whole lot of stuff here. But it's going to get a little bit simpler, because this here, most of these here, get a little bit more complex and then get simpler once we actually start doing them. Now on top, the 3 and 3 will cancel. The x minus 1 and x minus 1 will cancel. The x plus 1 and the x plus 1 will cancel. In the denominator here, these x plus 1s will cancel. X plus 1, x plus 1, x minus 4, x minus 4. So we look back at this here in our fraction. The only thing left in the numerator is x minus 4. Everything else simplified out. Now in the denominator, scroll down a little bit, In the first spot, we have 15 times x minus 1 times x minus 4 minus 3 times, well, the only thing left is plus 4 times x minus 1. Yeah. Then we get to this point here. Questions on this here so far? Okay. Now what we're going to need to do is we need to simplify the denominator. The numerator is as simplified as it gets, but we need to combine like terms. So what we're going to have to do is we're going to have to distribute these, multiply through. Well, x times x would give us x squared. X times negative 4 would be negative 4x. Negative 1 times x would be negative x, and negative 1 times negative 4 is going to give us plus 4. Minus 3. So again, we're going to do the same thing over here. X times x would give us x times negative 1 would be negative x, and 4 times x would be plus 4x, and 4 times negative 1 would be negative 4. Now at this point here, we can combine like terms to make it a little bit easier to work with. Because here we'll have x squared minus 5x plus 4 minus 3 times x squared plus 3x minus 4. All right. So we simplified a little bit, but we still need to simplify a little bit further. And now we need to distribute the 15, which would give us 15x squared minus 75x plus 60. Have to do the same thing with the negative 3, so we get negative 3x squared minus 9x plus 12. Questions on this here? Okay. Now, again, we can combine like terms. 15x squared minus 3x squared is going to be 12x squared. Negative 75x minus 9x is going to be negative 84x. 60 plus 12 is going to be plus 72. Okay. Now, this would be really convenient if 12, 84, and 72 were all divisible by 12. I mean, what's 7 times 12? What's 6 times 12? So they're all divisible by 12, and if I factor it out, I get this here. Now, I'm not going to labor y'all with actually how this factors, because this does factor the two sets of parentheses. Since the 6 is positive, the signs are the same, and they're going to match the sign of the middle term, so they're both going to be negative. Our factors of x squared are going to be x and x, and our numbers are going to be 1 and 6. So this here would be our final answer. And we wanted to get it all the way down to this point, was just on the off chance one of these parentheses ended up being x minus 4. Because if they were, then it would simplify on top and bottom. Now did it ask for restrictions? Or did it?
It gives you restrictions.
Okay, so it's not asking for any of the restrictions here because again, with these here, getting the actual restrictions is a little bit tedious because it's not just seeing, it would have to be seen where, for the most part, this whole thing would be 0 as well as kind of these here, but the book mainly focuses on what's going to make these 3 spots 0.
The restrictions on this are -1.
Yeah. So they're mainly looking at these two. They didn't take that one into account. So that is it for this here. And that is your answer.
Number 6 is the same way as number 5.
So that is 7.42, number 5. You want to look at number 6?
Yes, because it is the same way as 5.
Okay.
So it's 3 over x minus 2 minus 6 over x squared, take away 4.
Okay.
It's a lot. X minus 2, take away 6 over x squared minus 4. So that's over 3 over x plus 2 plus 1 over x minus 2.
Okay.
And the restrictions are -2
And 2. Now, looking at this here, for simplicity's sake, so this is problem number 6, x squared minus 4 is one we'll need to factor. Well, it's what? X minus 2 and x plus 2. So this is 6. Now, I'm just going to rewrite it as this here, as x minus 2 and x plus 2. Okay. Yep, is that going to do it? So we rewrote, let's highlight then, this here, because it was x squared minus 4, but we were able to factor to x minus 2 and x plus 2. And I did that just so, well, partially to save on a little bit of space. Is how we got that there. Now, we could combine the fractions on top and bottom and then divide it, but we're going to stick with the least common denominator.
x minus 2.
Which these really are the only things that appear in the denominators of any one of these fractions on top and bottom. And because they only appear once in any of the given spaces, you only have to have them once. And now we're going to multiply. So I'm going to leave this down here at the bottom, and I'll scroll up here in a minute. As well, I have x minus 2, and again, this whole thing is multiplied by the numerators of each one of these here. So we're going to have 3 times x minus 2 times x plus 2 minus 6 times x minus 2 times x plus 2 over x minus 2 times x plus 2. So we multiplied that by the two fractions on the numerator. Now we're going to do the same thing with the denominators, multiplying these by the top two numbers. So I have 3 times x minus 2 times x plus 2 over x plus 2. Plus, well, it's just going to be x minus 2 times x plus 2 because it's being multiplied by 1 over x minus 2. So this here is what we get. And I'm going to scroll down a little bit. After we multiply through, this is what we should have, is this here. I scroll down a little bit so it's not as confusing for what's actually in the fraction. Now what we can do is we can simplify on top and bottom of each one of these fractions individually. So this x minus 2 and this x minus 2 will cancel. Here the x minus 2 and x minus 2, x plus 2 and x plus 2. On bottom, these here, and again on bottom, these here. So really when we look at the numerator of this, I'm going to change colors. The first one, we just have 3 times x plus 2 left, minus, well, 6. Because everything in the sets of parentheses for the second part of the numerator all simplified. Now, if we look at the denominator, we have 3 times x minus 2 plus. So once we finish simplifying, this is what we have here. Now, we do need to simplify these fractions on top and bottom, so here we'll need to distribute the 3. 3 times x will be, okay. Let's look at the bottom. We'll do the same thing. 3 times x is 3x minus 6 plus x plus, okay. Well, the 6 minus 6, well, those are gone, leaving us with 3x. 3x, so now that's finished with the numerator, the denominator. Well, 3x plus x is, negative 6 plus 2 is, there is a greatest common factor of 4 on bottom. So we'll factor it out, which leaves us with an x minus 1. And that gets us to this here.
It wasn't satisfied.
Right. Some of these are harder than they appear. And we get to this here. We good?
Yeah.
So I would do number 1 with y'all here. But we'll see if there's another one, because 1 is actually already posted up.
Okay.
So I,
Number 8.
number 8? We're good with that one. Yeah. So I'm doing that not because I don't want to cover them in here, but if there's more than just, because we got 1, 2, 3, 4, we covered 6 or 7 this morning. So if we cover more this hour, that'd be even better. Does that make sense? So any other ones from 7-3? Yes, we'll look at 3. These aren't in any order. I'm just writing those up because those will be the ones listed up so far. So let's look at number 3 on 7.32. If you'll read it off for me.
X squared minus x minus 6x
Okay.
over 2x to the 4th minus 6x. And then divided by x plus 2 over.
Yep, I got it. Yeah, I'll have to rewrite it. 4x cubed on bottom. And this is x plus 2 on top. Now, with any of these division problems, the first thing and the main thing I would do is change it from division to multiplication. Before we do any factoring or anything else, the first thing I would do is change it from division to multiplication. Change it and flip it. The main reason I say that is because if we start factoring and doing other steps and you're not paying full attention to it, it's easy to jump straight into crossing stuff out and simplifying before you actually flip it and get what you need to get done. So on all the division, the first thing I would do before factoring or doing anything else, change it from division to multiplication and flip the second fraction. Now once we do that, then I would start factoring. Now looking at these here, well, 4x cubed is as simplified as it gets because it's just a term. X plus 2, well, that's as simplified as it gets because it's just x plus 2. So we're really looking at the first rational expression. Now the denominator is 2x to the fourth minus 3x cubed. It's only two terms, so most likely we only have a greatest common factor between those two spots. And if I look at this here, well, there is a greatest common factor of 2x to the third, because 2 is a greatest common factor between 2 and 6, and x cubed is in common between x to the fourth and x to the third. Well, if I factor 2 out of 2x to the fourth, well, I just have, it factors out completely. If I take 3 x's away from x to the fourth, I'm left with a single x. Minus 6 divided by 2 is 3, and x to the third factors out completely. Questions on this here? Okay, and that's it. So 2x to the fourth minus 6x cubed, we take out the greatest common factor of 2x cubed, and it's factored completely. Now the numerator, we have x squared minus x minus 6. So this here will be two sets of parentheses. Since the 6 is negative, our signs are automatically going to be opposite. One's going to be positive, one is going to be negative. Now the factors of x squared have to be x and x. That's the only way we can use this and have it be actual factors. Now we're looking at the factors of 6. 2 and 3. Which one's going to be positive and which one's going to be negative? Right, because with the x's, the only numbers with x is 1. So x times 3 is just still going to be 3. X times 2 is still going to be 2. It's not going to change the numbers value. So we're really looking at what is negative 3 plus 2. Well, it's negative 1. And as long as it's just x and x, we don't have 2x and 3x, a number in front of x, we can kind of add and subtract those numbers from each other, depending on the sign, and it'll tell us what we have. Okay. Now that we have everything factored, we can go on and multiply these together. Well, here the x minus 3 and x minus 3 will cancel. The x plus 2 and x plus 2 will cancel. Cancel out, simplify out. Well, we also have x to the third and x to the third. Those will simplify out. Well, what am I left with? Which is? Now we're going to have a few restrictions. And when we look for our restrictions, we're really looking in these spots here. Highlighter. Here, here, this, and this. Now, x cubes, what value of x is going to make just x is 0? 0. Whenever we just have that variable to a power where there's nothing added or subtracted to it, it's just going to be 0. So 4x to the cube, what's going to make it 0? Well, 0. How about x minus 3? 3, because 3 minus 3 is 0. And last but not least, negative 2. Because negative 2 plus 2 is 0. And we could set those equal to 0 and solve and get them. But this right here is our answer. Any other questions on this here or any of other ones from 7.32 that we want to look at?
So we should do the same thing
Number 4? Yep, and then factor and simplify as needed. Yes.
So we just factor it too.
I would factor out a 2x. Mm-hmm. So we good with 7.32? Yes. How about 7.31 or 7.41 or 2?
I have a question on this one.
Okay.
It's number 4.
Mm-hmm.
So I factored the 2x out.
Yes.
I have 2x minus 6 and x minus 6. You can't take those out because the parentheses are stuck together.
Right.
So do you just leave them apart? Or
Possibly.
you factor out this 2x, this 2x.
Mm-hmm. Here, I'm going to do it up there. Yeah. Because I don't mind doing these. Over. And then I think it was originally divided by 2x over 3x minus 3. Mm-hmm. Right, and that's a good first step is to write it as multiplication. So we would change it from division to multiplication. And this would end up being 3x minus 3 over 2x. So we just end up flipping that at the start. Now, when we look at this here, the first set of terms here, 2x squared minus 12x. There's a common factor of 2x. So 2 divided by 2 is 1. And if we pull an x out of x squared, we're just left with x. Minus 12 divided by 2 gives us 6. And the x factors out completely. Does that make sense? So I think it's making sure that you're just x and not 2x. Now the 2x down here stays the same. Well, hey, we're going to eventually, well, those two are the exact same, yes? So those will simplify out eventually. Now in the numerator, we also have 3x minus 3. Well, I can factor out a 3, which leaves me with x minus 1. And now all we have left is the denominator. X squared minus 7x plus 6. Well, since 6 is positive, the signs are the same, and they match the sign of the middle term, which is negative. Factors of x squared are going to be x and x. Yes. It'd be 1 and 6. Now that we have everything factored, we can multiply it together. Well, x minus 1 and x minus 1. X minus 6 and x minus 6. 2x and 2x. Well, that just leaves us with 3. I don't know why they set these up this way so it comes out to be a whole number, but hey, it works out this way. Now, we still need to look at the restrictions. Because again, we're looking at these spots here. Now, the 2x is telling me that x cannot be 0. Because the x minus 1 is not going to be 1 because we can set these equal to 0 to solve. And the x minus 6 tells me it can't be 6 because 6 minus 6 is 0. Questions on these here?
I have a question on the next one.
Okay.
I think it's just to get me started. Since this one's not a fraction, it's over 1.
Yes.
And then when you multiply it, is it 1? And then this just moves down to the
Yes.
denominator?
Okay. So let's look at this one here. It's number 5 on 7.32. So if one of y'all will read the top of it for me.
X squared minus x plus 6. X plus 2. It's x squared minus 6x plus 1.
So this is what we're starting out with, and really this is over 1. So just because it doesn't have a denominator written in, it becomes 1. So when we do our first step of flipping it, we change it from division to multiplication, and the 1 goes on top. And the x squared minus 6x plus 9 goes on bottom. So we just flip that second fraction. Now, at this point here, we would factor the numerators, or factor anything that is factorable. Well, 1 and x plus 4 are not. Now, the other two, x squared minus x minus 6, is going to give us 2 sets of parentheses, as well as x squared minus 6x plus 9. Now, for the one up top, x squared minus x minus 6, since 6 is negative, the signs are opposite. X squared is going to be x and x. And the factors of 6 that we're going to use are 2 and 3. I think we actually factored that one a minute ago. Now the other one, x squared minus 6x plus 9, since 9 is positive, the signs will be the same and match the sign of the middle term. We have x and x. And the factors of 9 we're going to use are going to be 3 and 3. Okay. And now that we have everything factored, we can go on and multiply these together. Now, one of the x minus 3's is going to cancel with one of the x minus 3's. Well, I think that's about it, because there's nothing else left in common on top and bottom. So on top, that's going to leave us with x plus 2. And on bottom, we're going to have x plus 4 times x minus 3. Okay. We couldn't simplify that. Okay.
Where is that number 5 on?
Number 5.
7.32.
Mm-hmm. X plus.
I got it right.
Uh-huh.
I got it right. No, I got the exact same thing that you got.
Yeah.
X plus 2 over x plus 4 and x minus 3.
And there aren't any restrictions, because the only restrictions that would occur is with x minus 3, because that's the one that was eliminated. But because we still have it in the equation, we don't have to include it. So this here would be it. Sometimes with big ideas math, I don't know what it is, but every now and then there's a real skinny looking x that will show up. I don't know how it shows up, but it might be a capitalized or something like that. It doesn't like it. It gets very picky. Does that answer your question?
Yeah.
Yes. Sweet. So there's different ways we can do this here. If we look at this here, well, this x and this x are the same, yes?
Mm-hmm.
If they're the same, they're gone. Four over 8 would be,
Yeah, 1,
and
2,
so it's left on top.
and then 2x squared. Okay.
Mm-hmm. Now we can multiply them together, and did it that way, where we had 4x y to the 4th
Mm-hmm.
over 8 x cubed y. And then went and simplified that way. So either direction works.
So the restriction.
Because y cannot be. Yeah, it's always, whenever we don't have anything added or subtracted, it's just those things, just a bunch of terms being multiplied. Most likely the restriction is just going to be 0. So, and this is, because you can read it off or I can take the Chromebook. Because sometimes it's hard to read these things as they are. So 7.42, problem number 3. So this one here is tricky a little bit. And I say it's a little bit tricky because of the 8x minus 20. Because we could multiply top and bottom by 8x minus 20 and 2x minus 5, but we don't have to. And the reason I say that is because if we look at just 8x minus 20, I'm going to erase this here in a minute. What happens if I factor 4 out of this? Well, 8x divided by 4 gives me 2x. 4 divided by 20 is 5, yes? Well, that matches the other two. It just has a 4. So really, what we can say is this here is really 4 times 2x minus 5. So multiplying by both of those isn't incorrect. It's not going to give you the wrong solution. The only issue is going to come up is at the end, once we get everything done, there's going to be a common factor of 2x minus 5 that we have to pull back out of the top and bottom because we put it back in. So anything we put above the least common denominator has to get pulled back out. So that kind of makes things a little bit trickier than they have to be. So sometimes, especially when doing these here, if there's anything that could possibly simplify or factor, let's try to do that and see if something like this here comes back out. Because with knowing that, it makes the least common denominator 4 times 2x minus 5. And really one of the ways that we can look at getting that is just seeing what's the denominators on each one. So we see 2x minus 5 once in each of the 3 spots, and a 4. So that there should simplify out each one. Okay. For spacing, I'm going to do the numerator first, just down low, and then I'll scroll up for the denominator. So when we multiply this, we're going to multiply it by the tops of these fractions. Well, when we multiply with 1, it's going to be 4 times 2x minus 5 over 2x minus 5. Minus. Now at this point here, we can do the multiplication of the 4 and 7 for this here, from going from here to here. But I notice I have the 4 down here, yes? So that 4 and 4 would simplify out. And if I know something that's going to simplify, it might just be easier to just say 4 times, 7 times 4 times 2x minus 5. So I didn't multiply that out because I noticed that, well, since in the denominator was 4 times 2x minus 5, there's not a whole lot of reason to multiply the 7 and 4 if we're just going to divide it by 4. So if I will multiply things together if I know that they won't immediately simplify, but if they don't, I'm going to leave them. Now let's do the denominator. So we'll have 4x times 2x minus 5 over 2x minus 5. So are we good with getting to this point here? And I think probably it was just that factoring it to 4 times 2x minus 5 is probably what would have helped. Because now all of this here simplifies because each one of these is in common on top and bottom. We can get rid of them. Which will really leave us with 4 minus 7 over we agree with that? What 4 minus 7 is? And that'd be your answer. Yes? Okay. All right, Ian, if you can read that off to me.
9 over x minus 3 plus 2x over x plus 1. That's it.
Okay, so we're looking at just these two here.
Yep.
So what we want is we want the denominators to be the same. Yes? So what does the one on the left have that the denominator on the right doesn't?
X minus 3.
So we'll multiply it on top and bottom. How about going the other direction? I think it's x plus 1, right? Or is it x minus 1?
Oh, you're right. X plus 1.
Okay,
Sorry.
you're good. So we're just making the denominators be the same for this here. So the denominator, well, we're not to that point yet. For both of these is just going to be x plus 1 times x minus 3. Now the order in which you write these really doesn't matter because multiplication, we can multiply any two things in any order. Now the numerators we're going to end up distributing. So we'll have 9 times x, which is 9x. 9 times 1 is plus 9. Now on the other set of parentheses, we'll do the same thing. So we'll have 2 times x, which will be 2x squared, and 2 times negative 3 will be negative 6x. Oh yeah, this was 7.41, I think.
Yeah. 7.41.
Number 10. Okay. Just so we know. Now, at this point here, we can add the two together. We can add these two together. Well, luckily with addition, it's not that we can do that a little bit easier than subtraction, keeping track of signs. Now, since there's no other x squared, it's 2x squared by itself. Now, 9x plus negative 6 is going to be plus 3x. And 9, well, just 9, is left on top. Now, in the denominator, we have x plus 1 times x minus 3. And that there, I believe, is as simplified as it gets. Now, if we wanted to, we could check to see, does this factor whole square root of, it'd be 3 squared minus 4 times 2 times 9. Yeah, this is going to be the square root of a negative number. At least I'm going to assume that 4 times 2 times 9 is going to be a bigger number than 3 squared. Well, it is. So, because 9 minus whatever that huge number is going to be negative. So we get this here, and because nothing's simplified out, there are no restrictions.
Can you? I know it's almost time to go. But can you help me on the next one real quick?
Sure.
I'm in the library.
Okay, 741, number 11. All right. So if you want to read it off to me.
Oh, yeah, sorry.
You're good?
12 over x squared plus 5x minus 24 plus 3 over x minus 30.
All right. So when looking at this here, it's very tempting to multiply both sides and go straight into trying to make the denominators be the same. But we need to hold on for a second, because x squared plus 5x minus 24, we need to factor it. Now, the reason I say that is because we're just making sure that this denominator does not have x minus 3 as a factor. Because if it does, then I don't need to do as much. So if we factor this here, well, since the 24 is negative, our signs are opposite. Factors of x squared would give me x and x. And it works out, the factors of 24 that end up giving me a middle term of positive 5 is x plus 8 and x minus 3. Okay.
So you already have an x plus 3, so we just do 1, right?
Right, because the one on the right's missing an x minus.
1's on the left.
Right, does the one on the left have everything that the one on the right does?
Yes.
Yeah, so we only have to change the one on the right. And that's why we factor this here, because if I'd have just multiplied by the quadratic, we would have gotten an x minus 3 extra on top and bottom that we would have had to factor out at the end. Now the one on the left is already simplified. We don't have to do anything with it. Now on the one on the right, we're going to have to distribute the 3 across the top, which will give us 3x plus 24 over x plus 8 times x minus 3. Now we'll add like terms. That would give us 3x plus 36 over x plus 8 times x minus 3. I don't think it'll count that wrong, but if it does,
Yeah, it does.
because there's a greatest common factor of 3 in the numerator, it's going to want you to factor it out. And the reason we do that is just in case, once we factored it out, it gave us something in common on top and bottom, which here it doesn't, and that there is just our answer. Does that make sense?